This is Powerbox-Systems iGyro SRS. If we turn it over, we can see exactly how to connect it up. If using JR or Spectrum, you would plug the satellites into satellites 1, 2 and 3 as opposed to directly into the Powerbox. Your fourth satellite can still go into the Powerbox as normal. Bus 1 and 2 are for all other non-satellite receiver systems, such as the Futaba 2.4. So we would plug receivers 1 and 2 into these two slots. If using the GPS sensor, this would plug into the GPS socket. And on the opposite side of the iGyro, we have 5 exits, which are marked as rudder, 2 for elevator and 2 for aileron. You can use all 5 of them to connect the iGyro to your Powerbox unit if using a patch system via 5 patch leads, or if using the serial receiver system, the S-bus, you would simply connect one receiver to the rudder, and if using a second receiver, it would be to elevator B. The iGyro will then automatically, once programmed, extract all necessary channels from the receiver via the serial receiver system. Okay, so plugging it in, let's see exactly how that would be when using the S-bus or serial receiver system. Here we have our competition SRS plugged in as normal via the S-bus to the receiver. For this example there's only one connected, but normally you would have 2. To connect it to the iGyro, we would disconnect the receiver and instead plug the receiver directly into the iGyro by means of the included patch lead. So plug this into the S-bus exit and into the bus 1, that is the first receiver, into our iGyro. And to connect it all to the Powerbox, we simply connect via the included lead again to the rudder exit. As we said, if we're using patch leads, we would connect all 5, or in the case of using SRS, the first one goes into rudder and the second goes into elevator. And here we go, one iGyro connected up. To use the iGyro, we need one free channel on the transmitter. This is the one that we're going to use to turn the iGyro on and off. For the first few flights with the iGyro, in which we program the amount of gain that we want for each channel, we'll need either 1 or 2 additional channels, simply so we can adjust the amount of gain in flight. However, once we've finished programming the gain, we can use these channels for any other purpose, such as smoke or lights or whatever. If you really are that limited on channels, you can also simply adjust the gain manually in the iGyro as opposed to in flight, simply adding on 5 or 10 more points of gain, flying, turning the gyro on, seeing if it's enough, and then turning it back off again if it's too much. In my case, I'm using this switch to turn the iGyro on and off. So this would be position for flight mode 1, which is gyro off, flight mode 2, which is gyro on, and flight mode 3, which again is gyro on, no different to flight mode 2, except that you can have 2 different gain settings depending on the type of flying that you're about to do. The main recommendation by Powerbox for this is to use flight mode 2 for the whole flight and use normal gain on all 3 surfaces, aileron, elevator and rudder, and heading gain on aileron and elevator, and then simply duplicate those exact same values but with the addition of heading gain on the rudder for flight mode 3, simply switching to flight mode 3 if we're going to do a roll or a knife edge and we want that little bit of extra support by the gyro. To set up that channel has been very simple. All I've had to do is go into linkage menu, function, and assign a free channel, in my case I've used channel 9, to the SC switch. So we've gone into control and selected the switch SC. Now, as we were saying, to adjust the gain in flight, we need to assign a channel to a trim switch or a roller switch on the transmitter so we can adjust it in flight. So again, very simply, in linkage menu, function, go to a free channel, in my case channel 10, and I want to use the trim T6. So we've selected control T6 and I've put it with 8 steps so that it's a little bit faster than normal. As I have enough free channels on my transmitter, I'm going to use T5 to adjust the heading gain as well. If we didn't have enough channels, we would simply use the first one to adjust the normal gain, and then in the following flight the heading gain. So just to see in a slightly more visual manner what we've done, I've assigned switch SC to my channel number 9, which is the one that switches between the flight modes, so gyro off or on. So in channel 9, when I move this, the gyro setting will go from -100 to 0 to +100. And the trims, we've assigned T6 to channel number 10 for a normal heading, and T5 to channel 11 for our heading gain. That's all the programming that we need to do in the transmitter. Adjusting the amount of gain that we want on our model sounds quite daunting or difficult even. Fortunately, that isn't the case. All we need to do is turn our gyro on with the trim setting so that the gyros are actually still basically off as they have 0 gain. And as we start flying, what we want to do is increase the amount of gain. As we do this, the model will get more stable. Now, the trick is we want to keep giving gain until the model starts to wobble slightly. At that time, we simply take a few clicks of trim back until it stops, and that is our perfect gain setting, because we have enough to make the model keep its trajectory in a perfectly steady manner, while also not having too much that the plane will give us that horrible wobble that we automatically think of when we think of gyros. The same applies to both normal gain and also heading gain. The iGyro comes with 2 different types of gain settings. The first one is what they call normal gain. This is what you would use to correct any kind of wind turbulence. So basically, if the wind makes the model jitter slightly, or drop a wing, or lift a wing, or even drop completely slightly, the iGyro with the normal gain will keep it in a straight line. The heading gain, on the other hand, is one that simply helps us keep a slightly more crisp trajectory. Basically, it helps us keep that straight line. An exaggerated example of this would be if we have enough heading gain on the rudder, when we go to knife edge, the gyro would want to correct in such a way that the plane would continue in that trajectory. So we wouldn't need to use any rudder input. Even though this sounds like something to play with on 3D models, this can be very helpful in scale models, just to keep that straight trajectory as opposed to the tail wobbles or deviations that they can sometimes have. Programming the iGyro. When we turn the model on, the iGyro comes on with it and will display the current temperature, the flight mode that we're in, being what position our gyro switch is on our transmitter. So flight mode 1 is gyro off, flight mode 2 is gyro on, and so is flight mode 3. Both flight modes 2 and 3 are completely freely programmable, so we can program them both to be either identical, if we so wish, or with different gain settings for each one of them, simply depending on our flying style and the model that we're using. GPS, that currently states that it's searching. That will be because we're inside a building, but outside at the flying field, within 10-15 seconds, it will state that the GPS is logged in. Therefore, it's correctly connected to a satellite. Sensors in motion. At the moment, the model isn't perfectly stable as it's on my workbench, so it's currently saying that the sensors are in motion, albeit very slightly. To program the iGyro, we connect the supplied switch into the socket on the iGyro, as we have done here. And with the 3 buttons on the switch, we simply operate the iGyro as we wish. Aesthetically, it's the exact same switch as used in the Powerbox units, both for turning off and on, and on the newer versions also for programming. It works in the exact same way as those programming switches do. So set is the button that we use to enter, to accept a position or a command, and the buttons 1 and 2 are simply used to go up and down. In this case, it doesn't actually turn the model off or on at all. So we press the set button once to access the menu, and basically when setting up we want to start at the bottom and go up. So starting at the bottom, we have receiver settings. Here we indicate what type of receiver system we're using, be it the DSM-2 or X system as used by JR or Spectrum, M-Link for multiplex, S-Bus for Futaba, or the Jetty or HOT systems. In my case, as I'm using Futaba, we have the S-Bus selected. Now in the bottom right hand corner we have digital out, which can be either on or off. What this means is whether we are using a Powerbox unit that the receiver signal is received via the serial receiver system or the standard patch lead Powerbox units. In the case of a patch lead, this will need to be in the off position as it's using analog signal, whereas if we're using the SRS system, the S-Bus, it would need to be on the on position, and simply confirm with OK. Going up, we have general settings. Here we have to indicate which way the iGyro is installed in our model. Due to being able to install the gyro on its back, on its side, or pretty much in any 90-degree position inside the model, we have to tell the iGyro which way up or down it is. This is quite simply done by telling it which way the screen is facing and the switch connector is facing. So the screen can face either up or down, left and right, or back to front. Now in our case it is facing up, so we want the option up, down. The switch socket, which is this one, the one that we're programming with, exactly the same. We currently have it facing the front of the model, so we want to select the option back, front. If it was any other option, same as above, it would be a case of selecting left, right, or up, down. Interestingly, the iGyro actually performs all necessary mixes for both delta wing and V-tail completely on its own. So in our transmitter we would actually have the model set up as a normal configuration airplane as opposed to delta or V-tail. Again, confirm with OK. Continuing up, input mapping. Here we have the channels that our control surfaces are connected to. Basically we want to make sure that these coincide exactly with the ones we have on the Powerbox unit, as obviously we want any aileron corrections to take place on our ailerons, not on our elevators. Interestingly, this isn't actually as difficult as it looks. we can simply copy the adjustments from our Powerbox unit, from our transmitter, or even by simply moving that particular control on our transmitter, the iGyro will automatically detect which channel we're moving. So if I now move the elevator, it selects 5, and if I move the rudder, it automatically selects 2. So rudder being channel 2, we accept, and can go on to the next screen. This screen allows us to tell the iGyro which channel on our transmitter we are using to adjust the gain for each one of the control inputs. So to adjust the normal gain on the aileron, for example, I'm using channel 10 on my transmitter, which I've adjusted to a trim switch. So when I move that, it automatically detects channel 10. Perfect. Obviously, as we want both ailerons to correct the same, we will simply adjust them both to the same channel. Now for heading gain, if we want, and we have enough channels free on the transmitter, we can also adjust the heading gain using the exact same method in the same flight. We would simply adjust to another channel, such as in my case I've used channel 11, or if not, we'll simply leave it to 0, which would be off, and we could do it on a subsequent flight. With the setting as it is now, with 2 different channels, I could completely program both types of gain for the ailerons in one simple, short flight. Once I'm finished, I'll come back in here and put them all back to 0, so I can't make a mess of my setup. Going on to the next screen, we have the exact same setup, but for the elevator, all set to 0, so we can't adjust them, not until we finish programming the ailerons. And again the same screen for the rudder. Again set to 0, so we can't adjust it. I've started with the ailerons. If you purely want to use this gyro for, say, the elevator, there's no need to use it on the ailerons. Simply leave these settings to 0, so you don't adjust them to start with, and don't give them any gain, and only set up the channels that you want to use the gyro on. So if you only want to use the elevator, only use the previous screen to set up the trims for the elevator so you can adjust the gain for the elevators. And on the final screen in this menu we have the flight mode switch. This is the channel that we are using to tell the gyro when to turn off or to flight mode 2 or 3. So basically turning it off and on. Continuing up, we have airspeed settings. Really, this screen is only for information purposes, but it's always fun to know how fast we've been. So in this case, we've been able to do 282 kilometers an hour. Gyro settings. In this menu, we can see exactly what gyro settings we have for each channel on each position of our flight mode switch. So here we can see that in the axis aileron A, in flight mode 1, which would be the off position, the normal gain is set to 0 and the heading gain is set to 0. 0 obviously because the gyro is off. If I flip the transmitter switch to flight mode 2, so gyro on, for this example we have a normal gain of 91%, that's way higher than you would normally use, and heading gain of 28%. Now if I actually adjust the trims that we moved earlier on the transmitter, adjusting the normal gain, we can see this move as we adjust it with the transmitter, and the exact same thing for the gain heading. If I move the trim slightly, it adjusts the percentage. Direction. This is very, very important. You need to make sure that any corrections made by the gyro correct in the right direction. To make sure the gyro is working in the right direction, we want to give full gain and test with the gyro off that it doesn't move, and then that when it does move with the gyro on, that it moves in the right direction. So the nose would be wanting to go down, so we need to give up elevator, and the same for all surfaces. then obviously before flying reduce that gain back to 0 to start with. If it corrects in the wrong direction, simply use this option to reverse the direction that the gyro corrects in. Airspeed factor. This setting allows you to adjust the gyro sensitivity at high speed depending on the type of model you're using. Normally this comes set to number 2, which for pretty much all models should be sufficient. If you're using a very fast model, you can increase this. What this basically does is at high speed it helps reduce even further the amount of gain that you have, so you don't get any of that horrible twitching at high speed. And that's it, programmed. Once we're at the site and have the model fully put together, we also want to zero the gyro. What this does is it makes it learn the current position and knows that that is completely zeroed. That would be the neutral position. And there we go, time to go fly with our new iGyro. To exit the menu, we simply scroll down and it exits.